Okay, I'm sitting at home on a Saturday because my foot, which I sprained almost a week ago, hasn't completely healed yet. So I might as well crank out a couple of podcasts in the morning before I start watching cricket matches and so on. So this is a nice article. I know I keep summarizing papers from all journals without worrying about the quality, impact factor, and so on. So this is Frontiers in Marine Science, and this is a relatively old paper, but it's still relevant. And you can always hear good things and bad things about journals to the extent that they have some review process, and these papers have gone through some checks and balances. We can at least take, you have to look at the quality, of course. Anyway, animal-borne telemetry, an integral component of the ocean observing toolkit. So imagine all the technologies that are coming along now, materials, nano technologies, miniaturizing things, artificial skins, wearable technologies, biodegradable materials, batteries, so on and so forth. And ocean is full of life, and they are not looking for funding to measure things. You catch them and put some instrument on them without affecting their lives in any negative way, and they will happily keep collecting data for us. This has been going on. We do that on land as well. We tag birds and we tag animals, and land is easier. You can fly drones, etc. But the ocean is harder. Even though you have some autonomous vehicles, it's always so much of the ocean that remains unobserved, and it's a big part of the climate system as well. So we need to know not just hydrography, temperature, and salinity, and so on, but also oxygen, light, marine animal species distribution, biodiversity, etc., and how far acidification is going, and so on and so forth. Animal telemetry is a powerful tool for observing marine animals and the physical environments that they inhabit. From coastal and continental shelf ecosystems to polar seas and open oceans, satellite-linked biologgers and networks of acoustic receivers allow animals to be reliably monitored over scales of tens of meters to thousands of kilometers, giving insight into their habitat use, home range size, and the phenology of migratory patterns, and biotic and abiotic factors that drive their distributions. So there are whales that go all the way from the North Pacific into the Southern Ocean. For example, there are turtles, there are tuna, all kinds of migrations happen. Some birds, little birds, amazing. They fly from New Zealand to somewhere into the northern hemisphere, across into the Pacific. Not just directly across, but over. Anyway, so amazing how they do these things. Furthermore, physical and environmental variables can be collected using animals as autonomous sampling platforms, increasing spatial and temporal coverage of global oceanographic observation systems. The use of animal telemetry, therefore, has the capacity to provide measures from a suite of essential ocean variables, AOVs as we call them, for improved monitoring of the Earth's oceans. Here we outline the design features of animal telemetry systems, describe current applications and their benefits and challenges, and discuss future directions. We describe new analytical techniques that improve our ability to not only quantify animal movements but to also provide a powerful framework for comparative studies across taxa. We discuss the application of animal telemetry and its capacity to collect biotic and abiotic data, how the data collected can be incorporated into ocean observing systems, and the role these data can play in improved ocean management. Okay, so I'm not, the paper discusses a lot of things. I'm not going to discuss anything. I'm just interested in showing you the potential for crowdsourcing data using the marine animals. So here is a schematic: wind speed and wind directions. You can use birds to do that. Of course, satellite telemetry is always important because these animals collect data and they have to beam it out so that you can sit on land and collect them. Location, direction, behavior, foraging range so that you know how deep they are going. Then you can decide what to measure. So the feeding rates, rate parameters are always difficult. And if you just think about the open ocean, here is a ice shelf sticking out, or maybe sea ice, and you have large chlorophyll, so euphotic zone, and then you have what is called the mixed layer depth. Hopefully you know what that is. Well mixed turbulent layer, where you have generally isothermal and isopycnal, constant density, constant temperature kind of structures, but there are many complications. It's a very critical part of the climate system, because that's what tends to determine the sea surface temperatures, which is what tends to determine coupled climate variability at all sorts of time scales. Okay, current velocity, current direction, surface waves can be measured using some birds who spend time on the water, and you have depths here going down to 1200 meter. You have things like oxygen and other acoustic signals, etc. So using conductivity, which is a measure of salinity, temperature, depth, heart rate, dissolved oxygen, blood chemistry, etc. Along the way you can also measure hydrography like salinity and temperature. Looks like a little dolphin here, maybe. Some of them, big-eyed tuna, can dive quite deep. Some of the whales, many animals dive quite deep. Often we don't even know, so instrumenting them will tell us more as well. So light is always very important to track in the ocean, not just for how the processes of primary production are happening, but also how the heat balance is getting affected. These tiny microscopic algae can actually grow in such large numbers and act like clouds in the ocean and affect seriously global scale variability of climate because of their impact on heat content, sea surface temperature, etc. What is called bioclimate feedback or biophysical feedback. And mortality, of course, is always important. Acoustic detection, so you're going to measure masses of fish, for example, which could be forage fish. Infinite possibilities. I will just jump to a table that lists a lot of things that are hosted by different organizations, and the taxa that are used to do measurements, and that the regions that are covered, and the types of data that are gathered by instrumenting the animals. So let's not worry about this, but you have things like Acoustic Tracking Array Platform, or ATAP, Atlas of Living Australia, ALA, and here you have BirdLife, European Tracking Network, etc. And taxa used: marine animals, principally fish and sharks, Australian fauna, cetaceans, fish, pinnipeds, seabirds, sharks, tunnels, cetaceans, fish, pinnipeds, seabirds, birds, all marine species, and turtles used here as well. So regions: Southern Africa, Australia, and marine estate, Pacific and Atlantic oceans, including Arctic and Antarctic. There are some sample data shown in the paper as well that I'm going to skip, and some are global. So you have acoustic animal tracking, occurrence records, just in terms of presence, absence, oceanographic and climatological data, and animal movement and behavior, acoustic, archival, and satellite tags, oceanographic and climatological data, ocean movement and behavior, bird occurrence distribution and status. There is always some coexistence of dolphins, tuna, birds, and they all school together in some ways. And birds are watching the dolphins because they know that's where the fish are, and everybody is benefiting everybody else. Somebody gets eaten, of course. Okay, diversity, distribution, abundance of all marine species, oceanographic and climatological data. Okay, there are many examples, no need to go through all of them, but coverage can be global, which depend on seabird movement and behavior, and shark movement and behavior can offer global. Doesn't mean one shark is going everywhere, but sharks everywhere are tagged, let's say. And primarily Arctic and Antarctic oceans is done by marine mammals exploration of the ocean pole to pole, MEOP program. That's oceanographic and climatological data and animal movement and behavior, right? So you get the sense that this crowdsourcing can be tremendously useful, and we can hardly have enough data, especially because funding ocean observations has always been below what is needed in many ways for improving forecasts, for understanding climate change impacts. And of course, ocean takes up 90% or more of the additional energy we are trapping because of increasing greenhouse gases, and that heat is causing deoxygenation. There is CO2 going in, acidification. So you really need to understand the oceans. And it's been said for a while that we know more about Venus and Mars than our own oceans, although that may not be true, because a lot of the navies are quietly collecting a lot of data. But if it's not in the public domain, we don't know, right? But nonetheless, just from climate perspective, sustainability of oceans, sustainable exploitation of marine resources, and so on, we need data. And imagine the animals providing so much coverage, considering they're wandering around everywhere, diving deep, and so on and so forth. Okay, it's an exciting topic, and there are really amazing things now, like artificial skin. Imagine putting a very thin layer of artificial skin on top of these big giants or small things, and collecting data. And wearable technologies, we talked about wearable technology for cattle to monitor their diet and reduce their methane emissions and so on. So technologies now have infinite scope, especially with miniaturization technology, and also biomimicry and bio designs, nature-based designs, and so on and so forth. Okay, let's leave it here.